Hello, my name is Xie Lianxin. I am honored to share my work, learning degradation-unaware representation with prime-based latent transformations for primed face restoration. Primed face restoration aims to restore facial details in degraded images while preserving the individual's identity, even when the specific types and levels of degradation are unknown. In this work, we introduced a novel approach that performs price-based transformations on query key and value components during attention computation in latent transformer. To achieve this, we proposed a latent regularization method that synthesizes degradation-aware features and developed a price-based key-value module to effectively refine the degraded features. The proposed method can also be used to process out-of-domain data. This is the overall framework of our model. Below, I will briefly introduce the process of image restoration and each model in this framework. Given a degraded face image X, an encoder E extracts the preliminary feature Q from the degraded face image. A latent diffusion-based regularization module is applied to Q to obtain its degradation-aware feature Q hat as the query. At the same time, a price-based key-value module quantizes and transforms query to learn the key and value. We then perform cross-attention computation over Q hat, refine the key and value in each transformer block, and feed the resulting feature into a generator G to synthesize a high-quality face image. One of the proposed modules is latent diffusion-based feature regularization. In this module, we use a mapping network to transform encoded features into the input space of the diffusion module, producing low-quality representations based on the input image. We then add noise to it until the diffusion module can distinguish between high and low quality representations, enabling us to calculate transition probabilities and perform reverse diffusion. To prevent semantic deviation from the original input, we introduce a variable-based information injection module that preserves semantic information by recombining high-frequency and low-frequency information during reverse diffusion. This results in a de-noised and regulated representation while preserving the semantic of the input image. Another proposed module is the price-based key-value module. We apply the self-attention to map the preliminary features Q to Z. Their features are then sent to a pre-trained dictionary for top D matching, identifying the D most similar elements. Last, we employ a learnable global mapping layer to determine the linear compilation coefficients among the elements. Using the coefficients, we represent the retrieved dictionary elements. Finally, the transformer module adjusts the expression of the feature, using the corrected key-value features. After the degraded query key and value features are corrected by the aforementioned two modules, a cross-attention calculation is performed to attain the final corrected representation. This representation is then sent to the decoder to restore the high-quality image. Here are our experimental results. The figures below demonstrate that the regularization module effectively corrects degraded features. Comparative experimental results indicate that our proposed method can restore realistic facial images and achieve impressive quantitative metrics. We conducted aberration experiment. The results show that their modules are crucial in detail restoration and maintaining ID consistency. That's all. Thank you for your attention.